Thank you. Thank you.
Thank you. Thank you very much, Nicola, and good morning, everyone. It's a pleasure for me to start this first webinar of the training with you. My name is Zaka Adam, and I coordinate this program with Arnaud, and more specifically, I'm in charge of the statistics part. Today, I'm also accompanied by my colleague, Nicola Cohen, who is an expert on Nigeria energy statistics, and he will be helping me today answer any questions you may have on the training course. I'm very happy to share our knowledge and to learn from you more about Nigeria energy sector. And before we look at modeling and projections, we need to look at to work on statistics. Some of you are professional energy statisticians with years of experience. So what we will discuss today may be obvious to some of you, but we will try to bring our broader perspective, as the IEA has been working on statistics for nearly 50 years and with over 120 countries in the world. And it's very important that we all share the same language and have a common base of understanding. So let's get started. So this is just a summary of the agenda. So today we are on webinar 1, where we will work on the statistics, fundamental of statistics. And then tomorrow we will look at the energy statistics by fuel. Then on Thursday, we will look at energy balances and CO2 emissions. And on Friday, we will look at energy prices and taxes and energy efficiency indicators. So that will be the first week where we focus on statistics. Then next week, we will start working on modeling, where depending on when Eid al-Adha will be, we will adapt the timing. So we will look at the different parts of modeling. And the last week, we will also look at sustainable development goals, 7.1, access to clean cooking and electricity. And on Friday, 30th of July, we will do a wrap-up quiz and closing of the training course. Before we start with the technical part, let us quickly look at some of the housekeeping rules to make sure that our session today and in the coming days are the most effective. So the entire event will take place in virtual using the Zoom meeting platforms. We recommend that microphones be turned off during the presentations to avoid background noises. If you have an important or need an important clarification during the presentation, you can raise your hand, and then we will pause the presentation to clarify your doubts. But otherwise, you have the Q&A box where you can write down all the questions you may have for us. And after the presentations, we will make sure that we answer all the questions that you send us. If we don't have time to answer all your questions, you can send additional questions to my email, to Arnaud, and also to the Africa program at iea.org email address. This first slide, it's to show you how the data and modeling work of the IEA has permitted to estimate the impact of the COVID-19 crisis on different energy and climate indicators. A first striking discovery is that energy investments decreased in 2020 by more than 18%, or almost plunging by $350 billion, mostly due to oil and gas investment dropping dramatically in the upstream, midstream, and downstream. Energy demand decreased by more than 5%, led by a drop in the use of fossil fuels. Especially oil products witnessed a sharp decrease in its demand for transport, being strongly affected by lockdown measures and restricted international travels. This also caused a historical decrease in CO2 emissions, which was good news, but in order to achieve long-term sustainable goals, the opportunity of the crisis should be used to design recovery plans with a strong decarbonization focus. Our recent 2021 analysis showed that, unfortunately, in 2021, emissions will increase. Another good news was that in 2020, renewables emerged as the only area able to contrast the trend. The pandemic has also had an impact on progress towards the Sustainable Development Goal 7 of reaching universal access to energy. Sub-Saharan Africa is now home to 3/4 of the global population without access to electricity. The number of people without access to electricity has been decreasing since 2013, thanks to the progress made in several countries such as Kenya, Senegal, Rwanda, and Ghana. Still, this progress is being reversed as population without access to electricity is set to increase again in 2020 by 13 million people in sub-Saharan Africa and by 15 million people globally compared to 2019 levels. This is due to several reasons. First, the pandemic has forced governments to shift their immediate priorities to purely emergency measures, resulting in a lack of financing available for expanding and improving electricity infrastructure. Then private companies deploying decentralized energy solutions such as solar home systems and mini-grids have faced operational and financial challenges. In addition, the pandemic and its consequences are also affecting populations that are already connected, preventing them from paying for modern energy services. By the end of 2020, up to 30 million people who had access to electricity in sub-Saharan Africa will no longer be able to afford basic electricity services. As a result, in 2020, close to 600 million people live without access to electricity in sub-Saharan Africa, with 5 countries being home to half of them. The future is very concerning, and a delayed recovery would see population without access to electricity increase to 630 million in 2030, a time when sub-Saharan Africa will concentrate 85% of the global population without access. A similar pattern is being observed for clean cooking, with population without access growing to 1.1 million by 2030, while in the immediate future, millions of households in rural or peri-rural areas at risk of backsliding from modern fuels to charcoal, kerosene, or fuel wood. Now, let us do some interactive warm-up questions to test a bit your knowledge on energy statistics. Can I please ask you to connect to www.menti.com website and use the code that I will share now. So please connect to www.menti.com and use the code 21039111. Can you please connect to www.menti.com and use the code that appears on the screen, 210391 and 11. So the first question is, what are the units used in an energy balance? And you have 4 possible answers. Is it physical units such as cubic meters, tons? Do we use energy units such as megajoules, kiloton of oil equivalent, British thermal units, or do we use financial units such as dollars, euros, or you don't know? So I will give you some time to answer the first question. I really, again, recommend everyone to participate actively to these interactive sessions. So please connect to www.menti.com and use the code 210391 and 11. So we have 24 participants who who have replied already, and most of you think that it is energy units that we use in an energy balance. We have 2 participants that think that it is physical units, and 2 that said, I do not know. It's really good that we have a very high participation rate. And indeed, most of you were correct. And the right answer is energy units. So in an energy balance, we use energy units, and we report all the different products in the same energy units. And it is in the statistics balances that you can use physical units, but in an energy balances, we use energy units. Next question, what is a calorific value? Is it the quantity of energy contained in a unit of fuel, such as megajoule per kilogram? Is it the temperature at which a gas changes of phase, for example, in degrees Celsius? Or is calorific value the monetary value or price of a fuel per unit of energy, for example, dollars per megajoule? I'll give you some time to answer. What is a calorific value? During this training today, we will look at the definition of a calorific value. Why is it so important to collect calorific values in addition to the quantity of fuel consumed or produced? The calorific value is a very important part of the data collection. And we have 38 participants who have replied, and most of you think that it is the quantity of energy contained in a unit of fuel. Very good, and the correct answer is indeed a calorific value is the quantity of energy contained in a unit of fuel. Next question. So with which institutions do you cooperate for energy data work? Here, this is an open-ended question. You can write down the different institutions that you work with. Is it the ministry, the different agencies you might work, power plants? Please tell us with which institutions do you cooperate for in your energy data work? Ministry of Power, we got someone. University, SE for All, USAID Power Africa, Energy Commission of Nigeria. Many people are saying Ministry of Power, the World Bank, university, energy sector stakeholders. This is really interesting for us to know, because you will see later that my colleague Nicolas Coherent will show you the data that we collect for Nigeria, the challenges we are facing, and we are really looking to cooperate further with different institutions in Nigeria in order to improve the statistics that we collect. So knowing the different institutions that you Nigerians are cooperating for your national energy data work, it's very important for us. So we have got a lot of institutions with which you work, and it's very interesting. Thank you very much. So now let's get started with the presentations.
So let's start with discussing the basics, since energy data and statistics are the foundation that gives the ability to understand the entire energy systems. As we all know, energy plays a key role in our economies, societies, and lives. Having reliable and high-quality data and statistics has always been a concern in the statistical community. Still, several decades ago, quality was not as good as today, and there were inconsistencies in the methodologies used. Many organizations were not using the exact same definition and scopes, so there was a need for harmonization for a common framework establishing standards. Today, the framework exists. It is the IRIS. It enables us to speak the same language. It is a comprehensive framework on the scope of energy statistics, classifications, units, methods, data collection, institutional arrangements, quality assurance, and dissemination. The IRIS has been approved by international organizations. In the early 2000s, the IEA undertook an initiative to organize a group, the Inter-Enerstat, composed of various regional and specialized agencies active in energy statistics. This group acts as the secretariat for the IRIS under the UNSD. It provides comparability of production, transformation, and demand flows over all products. The IRIS has been adopted by most international organizations, including in the African continent, the AFREC, and the West African Economic and Monetary Union. As having reliable and harmonized data is key for analysis and decision-making, we advise all countries to refer to the IRIS for their statistics. How do we structure energy data to get a picture of a given region or country? The key split is supply and demand. In the supply side, first you have the production in the country and from other sources. Then you add imports and you extract exports. You can consider international bunkers. There are several methodologies for this and stock variations. As you can see, for stocks, you have arrows in both ways. Stock levels are a very important indicator in data analysis. On the demand side, you have first the consumption by the energy sector itself and for transformation. For example, for refinery, you have the transformation that is converting crude oil into gasoline. You also have the industry own use processes like the steam crackers to create heat. Second, you have the consumption by end-use sector broken down by industry, transport, residential, commercial, agriculture, non-energy use, and many more. The two sides normally should match, but in reality they don't, and that's why we have statistical difference. Statistical differences can show the data quality and therefore is a very useful indicator. So statistical differences can have a meaning by themselves. This breakdown by supply and demand work for several levels, at a country level, but also at aggregated regional levels. In which units shall we treat energy data? We need to agree on a common language. We all know many energy units. If in volumes, there are liters, cubic meters, barrels. In mass, there is grams, tons, pounds. And in energy units, you have the ton of oil equivalents, ton of coal equivalents, you have joules, watts. So we need to express information in energy units, and to do so, we have to convert from physical units to energy units using a conversion factor, which is the calorific value. The calorific values represent the heat obtained when the fuel is combusted. It is an indication of the quality of the fuel. The higher the calorific value, the higher the energy contained by unit of volume per weight. Therefore, it is useful to understand the quantity of energy. If you want to generate as much energy as possible, and I ask you to choose between 1 cubic meter of wood, 1 liter of oil, and 1 ton of coal, you need to know the calorific value to make the best selection. So calorific values have variations, and it varies among fuels and within the same product depending on the quality. See here the example of Morocco and South Africa, where you have the same product, which is bituminous coal, but with different calorific values depending on the quality. So whenever you collect energy data which is usually in physical units, you need to also collect the associated calorific value. It is even more complex as there are 2 different calorific values, which is the net calorific value and the gross calorific values. When you burn a fuel, you get the useful heat and water vapor that is not recoverable. Gross calorific values includes both, that is the energy of the fuel and the energy in water vapor coming from the humidity in the fuel when it is combusted. Whereas the net calorific values, it includes only the useful energy. Therefore, gross calorific values is always higher than the net calorific value. When a calorific value is reported, it is important to also ask whether this is on a net calorific value or gross calorific value basis. From one, you can calculate the other with standard ratios. Now, let us look at an example. When a country reports its energy data, it is usual to give one unique number for the physical quantity and one unique number for the calorific values. Here, let's take the example of a country with 2 fields of gas. Each field has a different calorific value and produces different quantities of gas. When you compute the total gas production, what calorific value will you use? In this case, we have to report the weighted average calorific value because it will take into account first the weight of each source of gas, and second, it will provide us a better estimate of energy supply and demand figures. Wrong net calorific values could bring to statistical differences, over-reporting or under-reporting in energy units. Now we know that energy data will be reported in energy units. Let's see how to present all the energy data of a country. At the IEA, we use an energy balance. In the energy balance, all the flows and energies are represented in a single table, and everything is reported in a unique unit, which is the KTOE, kiloton of oil equivalent. You can choose another unit, but you just need to specify it. The energy balance is structured as such. First, in the rows, we have the flows, which is first on the top part, you have the supply. Then you have the demand, which includes the energy sector own use by a refinery. For example, you have the transformation, for example, from gas to electricity, from crude oil to oil products, and you have the end use consumption. In the columns, there are fuels and energies, and given that we are reporting everything in the same unit, you have on the right the total column. All this is very useful because all the energy data of a country are included in a table, and you can easily see the key information such as what is the first fuel in the energy mix in terms of supply, what is the first source of energy to generate electricity, which sector consumes the most energy. You can also compute sophisticated indicators such as energy self-sufficiency. Now that we are all clear on the basics, let us discuss more the process of collecting data in a given country. Here we present generalities. Everything might not apply to your country's context, but it comes from our experience of working with several countries. In view of the role and importance of energy statistics, one would expect basic energy information to be available in a reliable and timely way, but it is not that easy. If we want to have detailed and reliable energy data, it is helpful to have an entire ecosystem and set of enabling conditions. First, we need to have a collection system, and this includes several pillars. A legal basis with statistical laws and other national laws and regulations where reporting of energy data would be mandatory. The legal framework creates a necessary foundation, but it is not sufficient for energy statistics. We need to establish institutional arrangements to ensure collection and compilation of energy statistics in the most efficient way among all the relevant members of the energy statistics system. Another pillar of the system is a proper reporting and dissemination mechanism, which means questionnaires compatible with international standards, a network of contacts, and a data release calendar. It's better to work on data collection when you know for what publication you're getting the data and when it will be released. We also need to review the methodology, anticipate and adapt to changes and new challenges to meet national and international needs. For example, it is now more important to focus on new renewables and their full contribution to the energy system than in the past because of their particular challenges and their growth. Collecting any statistics has a cost. However, lack of data quality could lead to even higher cost, and there should be a balance between the efficient use of resources and collecting what is necessary. What is necessary will depend on the needs of data users. However, not all needs will be possible to meet. It is important to look at the changes in the energy sector and to limit the collection by cooperating between the relevant government agencies. Cost is one challenge, but there are others. There are challenges of specific trends or new type of energy activities. For example, biomass data collection is very challenging. Off-grid data is a new trend. The liberalization of the energy markets, which has two major impacts on statistics. First, while in the past we could obtain detailed information from a single national company, now many surveys are required to have a comprehensive view of a sector. Secondly, a competitive market often leads to confidentiality issues that add to the difficulty of collecting basic information. Other challenges are lack of resources and also the forced turnover of staffs. The process has several steps. We have to collect data, verify them, process data, and then disseminate them. Here we illustrate the data chain of energy statistics. Let's imagine a real activity. In a gas field, we extract gas, which is production. It is sent to the power plant, which is a transformation, and then we use the electricity for powering air conditioner equipment, drive an electric vehicle, and this is the end-use consumption of electricity. The data for all of these activities needs to be collected, and this step is called primary data collection. This is where you might be involved. That is, discussing with the utility that reports the quantity of gas used for power generation, conducting the surveys to households to understand how many air conditioners they have, looking for information on the consumption and efficiency of an air conditioner, etc. Then, national administrations submit these data to international organizations in a certain standard format. For the IEA, it is mainly the energy balances. These data will be consolidated with others of other regions and compared to previous years. Once enhanced data are available, they can be used by first governments to shape energy policies, for example, to support electric two-wheelers or energy efficiency standards for air conditioners. Then it can be used by the private sector and investors. And it can also be used by the civil society. NGOs can look at the CO2 emissions and call for more policies to reduce energy-related CO2 emissions. Who are the players involved? In terms of players involved in energy statistics, one of the most important one is the Energy Ministry, which sets policies of the country, and the other one is the Statistics Office, which is usually in charge of statistical compilation within the country. Usually, some processes exist between the two for sharing data. The ecosystem is made of many other stakeholders, which are all very important, and collaboration between them is key. Energy regulators might have a lot of data, but they would have an incomplete view of the supply side without trade data. This is true for imports of fuels, but can also be interesting for off-grid solar systems or solar panels. Information on the demand side will also be incomplete without some form of comprehensive surveys. Ministry of Transport may have data on cars and trucks that will complete your understanding of energy statistics. The Statistical Office and Energy Ministry can then hold large amounts of data, but further collaboration is needed to make sure that appropriate outputs are disseminated and used accordingly, and that the right institutions are involved at each stage. What tools can be used for getting data? There are several possible sources, such as administrative sources. You need to check first before starting, because maybe some data are already available. The second one are surveys. It's quite challenging and we need to be careful when we do sampling. The advantage of surveys is that if you have existing surveys, you can just add a question. Example, asking a question on source of lighting, fuel for cooking during a demographic and health survey. Metering. Metering is very relevant for energy infrastructures, energy transformation, and for industrial consumers, but it is costly. Another tool is modeling. We do not mean to make projections and forecasts. What we mean is that we can estimate historical data based on proxies. For example, in 2018, you have a survey that gives energy consumption of household. You can define a proxy based on incomes and calculate for previous years if you know how this proxy has evolved. One important point is statistical confidentiality. Confidentiality should be taken very seriously. It is necessary to prevent unlawful disclosure of confidential data. But in some cases, confidentiality can be used as an excuse for not disseminating data. Solutions can be found in order to have more published data. And so a dialogue between the government and the private sector is needed in order to ensure that the data becomes accessible and treated without negative consequences for the company providing them.
Now, now I will pause here to see if you have any questions for us on this first part of the presentation. Please use the question and answer box to send your questions to us. And Nicola and I, we will be happy to reply to you. We already got a few questions on the sharing of the material. So all the sessions, all the webinars of this training, after each webinar, we put all the recordings on YouTube, and we will share with you the link so that you can watch it after again, and also have access to all the material. So please let us know if you have any questions before we move on to the second part of the training. No questions?
And also, I saw there was one question regarding the size of the energy balances. We will have another discussion a little bit later tomorrow, probably, where I will go a little bit more on detail regarding Nigeria energy balances. And then I think we should also, if you want, there will be discussion groups and also where we could also discuss and go a little bit more in detail with those tables. So for now, focus on the overall logic and a mechanism that we are putting in place there, and then we will go in more detail with the tables there.
Yes, and then on Thursday we will also be looking at in details at the energy balances and the different, how to calculate an energy balances, how we move from energy statistics to balances. So there will be like a full session dedicated to that as well, on the methodology. There's a question on, give us a simple and clear example on how to calculate an average calculate the average weighted calorific value. I think we had a slide on that. Maybe I can find it and share again while you say a few words.
So yes, for the calculation of the, I think it was coming a little bit after, no? Maybe it. It's in the second half, I think. Anyway, just for the overall logic of it, it's when you have several sources of the same fuel within a country. Let's say you have the domestic productions and the importation of the same products, or two fields producing different qualities of natural gas or crude oil. You would have products that have a different net calorific value. Some will be will have more energy content than the other. So the way to calculate this is pretty simple. It's a weighted average. So you multiply each respective calorific value by its associated quantity. So in this case, in this example here, it's the production quantity. So you multiply those elements, you sum the results, and you divide it by the total production, the total quantities in your countries. And this will give you the average value that you can use and apply in some tables where you would aggregate all those elements together. So that's why a collection of good detailed data on the various field productions and on the calorific value associated is important, because if you lack one of those values, you would end up with a wrong calorific value for your overall database, which will have implication on the energy balances, and then, for example, in that case, on the CO2 emissions, for example, or on the indicators you will build with those values.
Thanks, Nicola. Indeed, it's very important to use weighted average for calorific values, because that's what gives you the most realistic value. Because, for example, some field, even for consumption, you might be consuming 1,000 MTOE of one fuel and someone else is just consuming 10. And if you do a simple average, it doesn't reflect the reality about the proper calorific value. So it's really important to make the, to weight properly. There's a second question. Is there a session that touches energy institutional arrangement or framework of Nigeria? So we don't really focus on, in the training, we don't look at detail for Nigeria itself. We look a bit at the broader energy institutional arrangement, and but we are happy to discuss with you on this. There's another question. The formula on calculation of weighted average, is this the simplified version or there are more complex ones? No, I mean, this is like the generic formula, and I mean, it's not more complex, but it also depends on how many. For example, in this case, we are taking an example of 2 fields, but maybe you have 10 fields, or so then it makes it longer, the formula, but it's the generic method. Do you have other questions? If not, then let's move on with the second part. I will, let's do a few more Menti questions now before we look at the second presentation. So again, can you please connect to www.menti.com and use the same code as before? So 21, 03, 91, and 11. So please connect to www.menti.com and use the code that appears on the screen, 21039111. And the first question is, what are the types of checks you can apply to energy data to ensure quality? So the second part of the training today will be focused on data validation. And so we would like to see if you know a bit about the different types of checks that you can do to check that your data is of good quality. So here you can write down, I see some names. Cross research, yes. You can do time series consistency. Indeed, it's very important to make sure that your time series makes sense. There's no outliers or big jumps or big decrease that you cannot justify. Sometimes it's possible. For example, if there's a closure of a power plant or a new refinery that has been built, so then this makes sense. But otherwise, your time series needs to be consistent. You need to check your source, very good. Methodology adopted, yes, we need to use consistent methodology. You can check consumption, efficiency of your different transformation processes, indeed. Calorific value check, very good. So for calorific values, you will see later that calorific values, it's not a fixed number, it varies over time. So it's not normal to use the same calorific value for 10 years, 20 years. So this is something that you need to constantly ask your data providers to provide you with this information. Accuracy, environmental factors, time series analysis. Very good. Spot checks, back checks, yes. So yeah, we have a good list of different types of checks that you can do. The one that comes the most, it's validation, efficiency, calorific values, time series, the sources. You can cross-check with different sources as well to see if the data makes sense from different sources. Output levels, yes. So how much you input to a transformation, how much you get out, then you can calculate efficiency as well. So this is very good to have this different list of different checks that you can do. And during the next presentation, you will see a few that we will be giving you as well. Let's move to the second question now. If everyone has already replied, I see answers continuing to arrive. We have a very good participation rate, so I really want to congratulate you Nigerians for participating so actively. It's really good. So excellent. So let's move to the second question. How can you verify the fuel consumed, which is an input, and the electricity produced, which is an output, by a thermal power plant? So how can you check that your input and output make sense? Do you analyze the trend of production in the past years depending on technology? So you can, or can you compare the ratio of output and input with expected efficiencies by technology or source, or comparing the level of production output with similar countries? So think about it. What easy check can you do to verify that your fuel consumed and the electricity produced by a thermal power plant makes sense? I think before, in the previous question, many of you already mentioned it a bit. So I give some time for colleagues for participants to answer. So most of you think that it's by comparing the ratio output input with expected efficiencies by technology sources. So it's very good. Most of you were right. The correct answer is the best way to check an input and output is by doing the ratio output over input with expected efficiencies by technology and source. This comparison, it's really important that we do it for the different transformation processes that we have to make sure that our efficiencies is within a good range. Last question. What is the efficiency of a traditional earth kiln to produce charcoal? Here we are referring to a traditional earth kiln and not an improved one. So is it around 80%? So do you need 2.5 kilogram of wood for 1 kilogram of charcoal? Is it around 40%, so you need 5 kilo of wood to produce 1 kilogram of charcoal, or is it around 20%, so you need 10 kilogram of wood for 1 kilogram of charcoal? So what do you think is the efficiency of a traditional earth kiln to produce charcoal? Is it 80, 40%, or 20%? So I'll give you some time to think about it. So we have the majority that think that it is around 20%, but we have a few colleagues that replied around 80% and some who said around 40%. So here the question is really about the traditional earth kiln, so not the most recent ones. Give you a bit of time to think about it. So indeed, you were right. Most of you were right. It's around 20% for a traditional earth kiln. So you need 10 kilogram of wood to produce only 1 kilogram of charcoal, which is not much. So now let's move to the presentation.
Before we go back to the presentations, I think we had a
Yes.
question in the chat regarding how we managed to track, how we were able to track the technology changes in the country we worked.
Yes.
Well, how we track those elements, it really depends on if we have good data sources in the countries, and especially if we can communicate clearly with our contacts there. For example, in the recent years, we have seen changes in the residential consumptions regarding kerosene and LPGs. Basically, what we see is that the kerosene consumption in the industrial sector, so mostly for cooking, is decreasing in many countries in Africa, while LPG is rising. LPG consumption is rising. So what explains this is more, and what allows us to check it is mostly that in many countries, LPG ovens are becoming cheaper, and with a lot of helps to push the families and consumers to use those one. So this lead to changes in first the trade of the country or the generations if it's producing countries. So you would see more importations of LPG, less of kerosene. And if we can validate those elements with our contacts, we can then find the origin and explanation on this technology change specifically. But this, as I said, is all depending on the quality of our sources and the information exchanges and questions that we can have with our focal points there. Because if we lack good information, we might also sometimes miss technology change if we are not made aware. But since we are not there, we are not in the countries, it's not always possible to track everything down. So that's why we are relying a lot on people there to help us improving the data. I think, but we can go that.
Yeah, thank you, Nicola. Indeed, the way we can track those changes in trends and technology, it's really through the different exchange we have with the national contacts, and also with the different divisions also that are doing analysis on of the different fuels and technologies, and we exchange information. And I also just saw that maybe engineer Farouk Yusuf, you wanted to say something on the weighted average, or not. Mm, Maybe we can come back to this after. So yes, so let's move on with the second part of the presentation.
Let's start with a summary of the recommendations to establish an energy information system. One should establish a solid legal foundation. Also, it is important to ensure institutional arrangements, to build up formal procedures to support confidentiality, and to establish a data collection strategy. One should also provide up-to-date metadata and follow the international standards and concepts. Let's now have a look in more details at the data collection strategy. First, to establish an energy data collection strategy, one should identify data needs, both on the national, on the regional, and on the international scale. Then, one should look at the data that is already collected by NSOs, by other ministries, by other public actors, private actors, and by international agencies. Once these are compared, we will be able to identify data gaps, which are the data needs that are not yet collected with the proper requirement levels. That could be on frequency, on level of detail, on definition, etc. Then, it is possible to establish a strategy to collect the required data and include it in the national data strategy. This should include a legal framework, the allocation of resources, and the procedures for data collection and validation. And this is what we will have a look at now, the data validation. Data validation is important to ensure good data quality. And data quality is defined with 5 main aspects. First, relevance. The statistics should meet the needs of the users. Then, they should be accurately and reliably portraying reality. They should be released in a timely and punctual manner and be consistent internally over time and comparable between regions and countries. And last but not least, they should be presented in a clear and understandable form, released in a suitable and convenient manner, and available and accessible on an impartial basis with supporting metadata and guidance. And for more information, you can see the links below. How to ensure data quality? We need to do different data validation steps. And the first thing to do is to check the internal consistency. Things to look out for are if one field is supposed to be the sum of 2 others, is it? Does the detailed breakdown match the total? Are stock changes correctly calculated? Is the dataset complete? Is the decrease in use of one fuel coupled with an increase in use of another one, or can you explain it with other reasons like efficiency improvements? And is the story logical? Then it is also good practice to analyze the data validation processes to identify possible points of failure and introduce checks. An example with this process A. Process A requires extracting fields, summarizing data, and reformatting data sets. It is easily happening that 1 or 2 items are dropped from the large data set. Because of this, one should compare before and after counts and the totals of data. One other aspect are the statistical differences. Indeed, when we collect energy data, we try to get a picture of supply and demand in a market. And in economic theory, we would expect that with an equilibrium, supply is equal to demand. The supply is how much is available to the internal market. The demand is how much was consumed in this market. In practice, as measuring supply and demand comes with challenges, and often we have different sources for the both sides, there can be a difference, which is the statistical difference, the difference between supply and demand. And this statistical difference can help us validate the data. Indeed, high statistical differences can be a red flag, often when it's more than 5% of the deliveries to the market. But we say that a statistical difference of 0 can also be suspicious, as it might mean that it was hidden in one of the commodity balances flows. So what can I do if an issue arises with the statistical difference? One should check the completeness and coverage of the data, check if there is double counting. One could have a review of the definitions and methods of data sources, check calorific values for supply and demand, and check if there are any new trends missing in the dataset. A specific example to verify electricity statistics is to verify the on-use and the transmission and distribution losses. First of all, the on-use. On-use of electricity by power plants as a proportion of production is not expected to vary significantly year on year. So this is something, when we map it over the time series, that we can use to validate the data. Similarly, transmission and distribution losses should not go above 10%, at least the technical transmission and distribution losses. However, it can happen that with bad maintenance of the grid or theft, we have higher transmission and distribution losses. We can see it in the graph on the right side. Several regions around the world are higher than 10%. It is just important to be able to explain these differences and potential changes from one year to the other. Calorific values are not only important to the energy balance construction, but they also allow us to check and validate the data. Indeed, for every energy product, there is an expected range for the calorific values. And that's why we will be able to compare the collected calorific values against default calorific values. We can also compare them with historical calorific values for the product, because they can be region-specific. And last but not least, one should check if the NCVs and GCVs used for consumption are in line with the ones used for supply, because this might lead to statistical differences. Another element that can help for data validation is the growth rate. This involves comparing the data point of the latest period to that of the preceding periods. And this is the formula. And if there is a high growth rate, one should be able to explain it by real-life facts. When seasonality is strong, or we are dealing with monthly data, it is often more useful to compare the current months with the same months of the previous year. And in general, this strategy is very useful for production and consumption, but less useful for stocks and trade. Breaks in time series can happen. You can see two examples on the right side in the graphs. However, we want to aim for a consistent time series. And if there is a break in time series, we want to be explaining it and to avoid unexplained breaks in the time series. Breaks in stocks are rare and should be investigated. And in general, certain flows are consistent over time, where then a sudden increase or decrease will raise a red flag. One example is the refinery intake graph on the right side on the bottom. Here you see that for 1 month, April 2005, we have a very small refinery intake. And for 1 month in December 2005, we have a very high refinery intake. While the first break in time series can be explained by maintenance, for example, the other one is more difficult to explain. And this is something that one should check, because usually refinery intakes stay quite constant at constant levels over time. Now let's have a look at transformation efficiencies. These can also help validate the data by looking at the relations between the input and the output. Indeed, for every energy transformation process, there is an input and an output, and there is a relationship between these two that will depend on the technology used. The efficiency will be calculated by the total useful output in net energy units divided by the total input in net energy units. For an example here, you have two inputs A and B and one output C. The efficiency will be calculated as C over A plus B, whereby the inputs and outputs need to be both in the same energy unit and in the same energy form. This efficiency then needs to be checked against the expected ranges for that process and technology. An efficiency larger than 100% is implausible, so that would be a first red flag. And then we will expect efficiencies to be within a certain range depending on the type of plant and the fuel used. They can also vary widely depending on the state of technology. A very old power plant will be less efficient than a very new one. And in general, efficiencies do not vary significantly from year to year as technology upgrades are time and capital intensive. Here is an example of the expected efficiency range, but this is very much country and technology dependent. So don't worry if you have an efficiency outside the range. It's just good to double check and to see if you can explain this difference. Another element to verify the data is to check if the data set is coherent. Are we able to explain trends in data sets? To do that, we can verify the data is coherent with certain related trends. For an example, we have here in sub-Saharan Africa the increase to access to electricity, and this is also visible in the increasing electricity generation. So here the two data sets are coherent. Then certain patterns may also be fuel specific. For example, natural gas demand and storage is linked to weather patterns. Hydroelectricity production is affected by rainfall, etc. Then one should also check if the data match related data collected through different sources. For example, the input to electricity production from electric utilities should match the fuel use in power by other sources. And in most cases, there are relationships among variables, such as the efficiency that we have talked about, that have to be satisfied. For example, if the inputs to power production are increasing, we expect that the outputs will increase as well. And a decrease in input without fall in output can be the result of improved efficiency. And this is the case on the right side for the gas power plants in sub-Saharan Africa. We had in 2000 an efficiency of 30%, and at the end of the time series in 2017, we have 40%. So this explains the difference between the evolution of the input and the output, the electricity production. Another data verification is to check the coherence with economic data. GDP and population data can serve as indicators of data consistency. One can check if the GDP or population is growing steadily, and if the energy consumption data makes sense in light of this. Long-term demand trends can also decouple from population or GDP because of efficiency or increased access. But here again, it is important to verify that the story is logical and that you are able to explain trends with real-time events. An example is here the total primary energy supply in the IEA. We see a dip in 2008-2009 in this total primary energy supply. And when we look at the gross domestic product in the IEA countries, we see the same dip. This is actually because there was an economic crisis, and so we are able to correlate one data set with the other one and to explain through economic data. Then it is important to have a look at different data sets and reconcile them when there is a different product classification. Because in general, goods can be classified using three systems: the harmonized system, HS, the Standard International Energy Product Classification, and the central product classification. And differences in product classification can quickly lead to discrepancies in data. For example, sometimes fuels with similar qualities can be named differently onshore and offshore, and categories do not always match. For example, biodiesel in the harmonized system can include up to 70% of oil from fossil origin. So this is important to note, and if you have two data sets and have difficulties reconciling them, think about the fact that there might be a difference in product classification. Then, you can also try and reconcile different data sources by mirroring checks. This is particularly useful for data sets with a bilateral component, for example, for trade. This helps ensure the consistent interpretation and application of methodology and avoids double counting or missing flows. The goal should be to limit, justify, and explain discrepancies when existing, and it's important to work with partner countries to investigate. The IEA can help you with this. An example on the right side in the graph with electricity trade. Here we see the electricity trade reported on the one side from country A, from country A to B, and on the other side in red, as reported by country B. We see that they were quite consistent along the time, and then around 2013 something happened and there was a big discrepancy between what both reported. So this is something where we would go back to the country and ask. Discrepancies can arise when we deal with trade data because of different methodologies, for example, physical flows versus contractual flows, or the country of origin destination might be changing. Then there can also be a problem with timing, and different countries may have different definitions. That's why detailed and transparent metadata is essential. Then we can also verify coherence when using monthly and quarterly data as an extra to the annual data. Indeed, good quality monthly data can be a tool for data validation as well as is key for energy security purposes. We see here on the example for LPG across the years that the monthly data had always been quite consistent with the annual data, except in 2016. So something to look out for are revisions and different definitions or coverage due to timing constraints. Again, in the example, the monthly data was always a little bit lower than the annual data, which points to different coverage, maybe timing constraints, because it's easier to have all the data for the annual, which is later on than for the monthly. However, in 2016, something happened because we have a much bigger discrepancy. So that would be something to query. Last but not least, if countries are not in a position to meet the accuracy and timeliness requirements, they can produce provisional estimates. However, note that these are based on less comprehensive data content. So what to consider? It is preferable, of course, that almost all data are real observed data. Estimates should only be used for flows and products that represent a small proportion of the balance. And they should only be used for a short time whilst a system of data collection is being established. Strategies will depend on whether the data needs to be systematically estimated or if it's only missing exceptionally and you know that it will be provided later on. Whenever a data point is estimated, this should be clearly marked and defined in the metadata. In general, we will ask the following questions when we estimate data. Is someone else already collecting this data or related data? This would avoid the time needed for the estimation. How important is the flow or product? This will tell you how much resources one can put into the estimation. Is it correlated with another flow for which there is data, which could help you to derive the data from that flow? Is there a seasonal or historical trend that can be used for the estimation? Why may this period be different? For example, have a look at the heating degree days for space heating. Can market trends be used as an indication or input for estimation? Last but not least, we will describe how the data validation processes are done at the IEA. an overview of how the data is processed and validated at the IEA is first, we will receive the data. Then we will process it, look at the inconsistencies such as the breaks in stocks, negative values, errors in sum, etc. Then we will do some time series checks, consistency, balance checks, seasonality and outliers, calorific values, and iterate with our data providers on these two types of checks. If we receive new data, we reprocess and we recheck the time series. Then we will have some more checking and peer review, where outliers and seasonality will be checked again, and then the database is frozen. And finally, we will disseminate our data. If you want to learn more about energy statistics, we have produced a comprehensive energy statistics manual that covers most of our data collection methodologies, and it is consistent with the IRIS framework. It is available in 10 languages, and you can download it free of charge. Furthermore, we have talked about it already, the international recommendations for energy statistics are available on the United Nations website. And we have also some manuals for indicators and policy making that are available on our website. The IEA data products include data services for purchase, but also free products on our website, including the keyword energy statistics, a data browser for data and statistics, the energy balance flows in form of Sankey diagrams, etc., etc. I invite you to have a look at our website. Thank you very much.
So thank you for listening. If you have any questions on that second part of the presentation on data validations, please write it down to us in the question and answer box. Do not hesitate. Just giving the participants a few seconds to send us questions. We still have like 15 minutes before the end of the training. So please don't hesitate to send us questions. We have two people who have their hands raised. Miss Safia Lawal Atiku, do you have a question for us? And I also see Mr. Ahmad Amin, who raised his hand. Would you like to say something? Also, Mr. James Obakpolo. Please, I have unmuted you so you can, I have given you the permission to speak. So if you have a question, you can either write it in the question and answer box.
Hello, good morning.
Hello.
Yeah, so a quick one. In which of the steps for the data validation and verification do we have regression analysis used to, to check integrity and data quality assurance? Thank you.
Nicola, would you like to say
Yeah, thank you very much for your questions. It's so that in the practical world, we are not using that much the regressions while checking the data. It could be used. It's when we are in a need to do some estimation. Let's say we have to estimate flow of consumption for a specific fuel or something. That's when we will do linear regressions with by doing so, trying to check if the, let's say, sorry, I'm missing a word right now, it's terrible. If the factors or the element we choose to help us do that estimations, the indicator, that's the word I was looking at, the indicator we choose for the for this estimation is valid or not. We try to do in that case a linear regression just to make sure that we are doing something that makes sense. But it's very, in terms just of just the data work on energy statistics and energy balances, it's not that used. We are not at that level of statistics most of the time. We are more looking at data management and checking the coherence of a time series. For example, if we see big breaks, as we say, or some weird changes, that's when we will try to find explanations more than to modify directly the time series. Linear regression will be more used when you start doing modelizations. So it will be in a few days in another part of the screen where we will be really going into those type of calculations. For now, we are more looking at basic data management elements.
Okay, thank you very much. Thank you.
If you have any more questions, please let us know. Otherwise, Nicola will make a small presentation on the data he collected for Nigeria and tell us a bit about the challenges that he faced while processing the data.
Sorry, I was muted. So yes, this will be a very short presentation, just reusing some of what you saw previously and applying them for Nigeria. So I hope you all see my screen. I see that you're nodding, so it should be okay. So just 5 quick slides. So just here is for Nigeria's energy balances. So what we have collected for 2019, this cycle, so this year, what we have been working on. And just as a quick reminder, so that we all have the same language elements. So we are working here in thousands of tons of oil equivalent, so in energy units. This is what we call the supply side, so all the flows from productions to stock change, and in TES you have the total energy supply of the country per products, and below you would have the demand part of the energy balances. So first the transformations, so for example the gas to electricity flows, but also for the refinery activities. And then in this specific table here you have the energy industry own use, and below you would have the final consumptions of the energy. I will explain later in just the next slide, but there's a reason why we do not go, I do not show below the TFC line. It's because we lack a lot of data to have a good quality to show in this kind of presentations. In any case, just also an overview of how we process the data in the IEA. So as you remember, we start by receiving the data, then processing it, so checking for inconsistencies, as I told you just before with the question of our participant. We check if there are negative values where there should not be, some error, inter-table error between the products, etc. So this is internally in our offices. Then we try to iterate with data providers. So in the case of Nigeria, it will be the contacts that we have in which these institutions or another, trying to see, okay, we have these changes we cannot explain. Do we have an information on that in the report, or can our contacts tell us, okay, this is coming from specific issues we had in a refinery, for example. And this cycle, we loop it several times until we are happy with the data, and then we go through the data preparations and then the publication phase. In the case of Nigeria, so here's a little bit edited one, we receive the data mostly from the NNPC, so the Nigerian National Petroleum Company, so it's annual reports that we are using, the Nigerian Bureau of Statistics, so using annual statistics that they publish on mostly crude oil productions and some trade, so trade of natural gas or of oil products. And then you have also the Nigerian Oil and Gas Industry Annual Reports from the Department of Petroleum Resources that we are using. And now there are also from NNPC and the department some monthly data that we are collecting from directly from their website. We have a little bit of difficulties to have direct contacts in Nigeria, so I suspect that most of our emails are ended up in some spams folder on the Nigerian side. But if any of you is willing to participate with the data exchange, we will be more than happy to have several persons to discuss, because the Nigerian energy sector is quite difficult and complex. So this is an interesting work to do together. So to complete the data that we like, we use what we call secondary sources from other international organizations. So that would be FAO regarding the biomass, gas for natural gas, and OPEC and AFREC for the other fuels. The issues we have with that is that we end up with inconsistencies between our sources. Let's say between NNPC and NODIA, we would end up with different value for crude oil exportations or the input into the refinery. We would end up with different values. This can be explained by the complexity of the energy industry in Nigeria, and also the fact that it's the various reports do not follow, I think, just exactly the same methodology in terms of fuel naming and flows naming. So let's say what we call the input to refinery will not be exactly the same in those reports. There will be a specific part for each flows if they are back and forth within the industries. So we try to correct that on our side in our data set, and at the end, we end up with some issues in our data. So the biggest one, the main one, are that we have for now the high electricity generation efficiency. So let's say we are for natural gas around 40% of efficiency. This is plausible physically, but it is kind of very high for generation. It would mean that natural gas generators in Nigeria are like some of the newest models that exist in the world. But maybe it's realistic. We just need some confirmations from you. We have also some issues, especially on the refinery part of our energy balances. We have a lot of energy gains. So this is kind of not good at all when you're talking about refinery, when you have gains, because it means you are creating matters from nothing. So this is not good in our historical data. And in recent years, we have seen a rise of losses getting very high. But I think on that case, it's more linked to difficulties and issues within the industry itself. So to discuss later on together if you're willing to. And finally, our biggest issue is that we lack a lot of information on the final consumption side. We have difficulties to find reports or data or survey that was done in Nigeria, maybe, we don't know if they exist, on the consumption, let's say in the residential sectors, or the consumptions of the cars in the country of diesel or motor gasoline. So just to sum up what we have in our energy balances, back at it. So we have the crude oil and oil products supply side, that would be supply side and beginning of transformation regarding the refinery, that will come from the Nigerian National Petroleum Companies report, but this is the main sources, plus the Department of Petroleum Resources reports. And then for natural gas data, we are using gas, and for the renewable energy and biofuel, we are using FAO and ARENA. Coal is still in our database, but we are estimating it using economical activities for the last 5-6 years. So as I told you, we have several sources already existing in Nigeria, but we have difficulties to find centralized information and to be sure about the data we have in there. So this is the last part of this short presentations. Nigeria is a very interesting and complex country regarding energy sectors, and at the same time, it is the biggest in terms of populations, and so in terms of population, energy demand, and requirements, and the development that are happening in the country are very fast, what I understood, and there are some interesting struggle that are happening. So what we need right now is more like cooperation and discussion together. This cannot be done just by us presenting element. And also here is the generic mail address that we are using for the data exchange regarding energy statistics. So this is not for the modeling part. This is only for if you are willing to, if you have data you want to share or you are interested in receiving Nigeria energy balances and give us feedback on it if you have information or comments. We will be more than happy to start this collaboration together and work on it together. So WED for World Energy Data at IEA.org. Please don't hesitate to share or discuss. This was really short, just to present to you the state of the art right now. So I leave the hand back to Zakia now.
Thank you. Thanks a lot, Nicola, for sharing with us the challenges you faced when processing Nigeria. I see that we have three questions in the Q&A box. So the first one was, which agency supplies wood energy data in Nigeria? So from what I saw, it's the FAO data that you're using for wood.
For wood, the FAO has done a lot of estimations and also specific surveys in several countries regarding wood and charcoal production. So using those values and past data that we could obtain, like I think the last official we had from National Bureau of Statistics for Nigeria, it was 2014 or 13. I think we had a value.
More than 5 years, yeah.
Yeah, more than 5 years. And then since then, we have been using those data to estimate and complete the time series until 2019. But yes, it's FAO that has been doing a lot of work on the ground directly there also to have some more realistic values.
Okay, and the next question is, what tools does the IEA use for data validation?
We do not use, I think if this is referring to maybe informative tools, we do not use specific like software or anything. It's mostly calculations and graphic or table creations for just basic data management on Excel and on our own database system. And then it's more that we check, we do the calculation on a time series view, and we will see, okay, those efficiencies are coherent between themselves on a time series. But if we compare, for example, countries that are at the same level of development on the same continent or else, and we see that there are real differences in terms of share of consumption of specific fuel in the sectors, or some efficiencies in transformation that do not match. For example, right now we have a project on biomass that is happening, and we try to compare the efficiency of charcoal productions in various countries in Africa. And seeing that, we could see, okay, for example, in the case of Egypt, they have industrial level of charcoal production, so we end up with a higher efficiency. That will explain why the efficiency in Egypt in our data was higher than, for example, in Ghana or Nigeria, where it would be lesser because there is more traditional production. So we move from 33% of efficiency in Egypt to 18% in Nigeria. So this is the kind of validation and work we do. It's not software. We do not have specific software. It's more like calculation and methodology.
Yeah, exactly. I think that once we save the energy balances in our databases, we have some automated checks. So all the data validation checks that you saw in the presentations, all of them, we do them, and we have automated all those checks through Visual Basics, and now we are moving to using Python. So we program all those checks so that it's run automatically, and then we have the results that come out, and we check and compare and make sure that everything is consistent. And then if we find problems, then we contact our counterparts, if we have someone to exchange with, then we exchange on the issues that we have. There's another question, time series check. So I see that we have a lot of questions on time series. So how can you correlate high generation efficiency with high ATCC losses in the country? Please need more elaboration on time series check.
Okay.
So
I'm not sure what you mean by ATCC in terms of value, but let's
is
say
it the grid, the lines losses?
yeah, okay,
I
this
think
okay,
so. Yeah.
okay.
Yeah. So it is aggregate technical, commercial, and collection losses.
Okay.
Like yeah, aggregate technical collection. Yeah, yes. I hope you get it.
Yeah. Thank you.
Okay, all right. So two questions. Please don't mention time series and how you find high generation efficiency with high generation efficiency. All right. Okay, I see what you mean. Yeah, maybe if you have a country in which let's take it on the other way around. Normally on a country with the electricity distribution system that is working properly with no big issue, no storm that will destroy some of the cables or no theft on the country, we would still expect, we will see that tomorrow on specific implementation, we would still expect some losses on the distribution system between 5-10% maximum, depending on the length. Also, in the wide country, there will be more losses because the length of the cables are more, so you lose more in heat losses in there. So you would always have losses. High efficiencies in generations are not that correlated with those losses. High efficiencies, it's more about the generator itself, the plant itself. If it's working properly, if the fuels are of good quality, if you are not, for example, using some old or bad quality fuel oil that will put some grease and elements within your generator, you would get a better efficiency. Also, if you're using more up-to-date and recent generators, you would have, for example, combined cycles that try to collect some part of the lost heat and reuse it in the turbines to help and produce more with the same quantity of electricity. But this quality of generations that will lead to a higher efficiency is not mandatory, is not linked that much with the losses of the system, because it's most of the time in many countries already the generations and distribution of electricity is managed by two different companies in most countries. So different companies would lead to different policies, and higher efficiency will not improve in any case the losses that you will get. So you will just lose more in quantity, but the percentage will still be there. And regarding the time series in general, well, there are different ways you can check that. You can check, for example, the percentage variations from year to year. So let's say if you are usually, for say specifically, you see that on 1 year you would gain or lose between 5% and 2%. You will check if this is still the case, if we are still in this average every year. And if you see 1 year where you had a big change that is very punctual, this would raise question on our side. Also, we would try to see if those time series, those evolutions, match the development of a country. Let's say we see a country that is developing with more access to electricity. We will check that the trends, the time series on electricity consumptions and generation match the fact that more people had access to electricity. So sometimes it's kind of just common sense what we try to check, but it's important also to go back sometimes to those basic elements of just does the story we are telling with these data sets make sense? And for that, it's always easier, in our opinion, to use a time series because you can monitor the evolution of a country if there has been a crisis, a war, or a natural phenomenon that have impact the country. We should see that in the data set. In many of our countries, for example, we can see the impact of the world economic crisis of 2009, 2010. In many countries, we see a small decrease in everything, in all generation and production, and then it's go back up. And for the COVID crisis that we see right now, we expect that when we will be receiving the data for 2020, we will see overall a diminution of industrial activities and a rise of residential consumption, mostly in OECD countries, at least, but also in African countries, for example, we would expect real diminutions of the trade part because there were less demand on oil side and natural gas side, so the trade of those fossil fuels will be impacted. This is the kind of thing we try to check with the time series that all the story makes sense altogether.
Thanks a lot, Nicolas. Let's take one last question. We are already a bit late. So is this data on wood or wood residues? I think he's referring to the FAO data that you use.
Yes, so we are, so the thing is on our data sets, in our methodology, when we publish the balances, we aggregate everything in what we call the primary solid biofuel. And these products, it includes at the same time wood residue and other solid biofuel that you could find in a country, let's say bagasse, for example, if you have a sugar industry in the country. So in these balances, it includes both, but for example, FAO, I think they report separately wood and wood residue when they can. So depending on the sources that you are using, sometimes they try to separate those elements. I don't know how reliable that will be, but yeah, that's just how we proceed now.
Thank you. I saw Mr. Ahmad Amin raise his hand, so let's take one last question if he has something to tell us. Mr. Ahmad?
Yes. Madam Zakia. I am Ahmed Bafamin. I am from National Bureau of Statistics, Nigeria. I am just joining, not more than 50 minutes. My first question is, how can I get copies of the lectures you've shown on the screen? This is my first question.
So no problem. So all the presentations normally before the training, we sent to you a Google Access drive to access all the presentations and the handbook where we will work from tomorrow on the exercises. If you have not received that, please write to me or to Arnaud or to the Africa program and we will send you the links. And anyway, after each session, as you have seen, we are recording all the sessions and we put everything on YouTube, and then you can access it whenever you want after the training. So so you will have access to all the material. And before I close, I just wanted to talk about the exercises that we will start working on from tomorrow. So you must have received a handbook that contains the exercises. It's a PDF file, but also the Excel file with all the exercises. So for tomorrow, we will work on an exercise on the statistics. And it would be great if you can take a look in advance of the training, try to work on that exercise. It's a small 15 minutes exercise, and then we can do the correction together and you can ask us questions on the exercise. I think that it's better if you take some time before the training to work on that one. So for tomorrow, it's the first exercise. And then on Thursday, we will do an exercise on balances. And then for Friday, we'll do another one on energy prices and energy efficiency indicators. So for tomorrow, just one exercise, take 15 minutes to try to do it. And then tomorrow, after the presentation, we'll do the correction together. together and answer all your questions. So I think it was a very fruitful and we had a good exchange. So I'm very happy about this first webinar. And thank you very much for staying all through the 2 hours, and have a nice lunch, and see you tomorrow at the same time. So 10 a.m. Abuja time. So I don't know if Mr. Farouk, you want to say something before I close?
No, just to thank you. I had posted a question. Yes, I think this is fine. We are very grateful for all the participants as well. And like you explained, the webinar sessions will all be online, so people can still watch them. I'm pleased to encourage everyone to try and do the exercise as requested by the International Energy Agency experts. Thank you very much. And see you tomorrow.
Thank you. So, and if you have any more questions on today's session, write to us. Nicola and I, we will be happy to reply to you and exchange by emails. And again, as Nicola requested, if you have any data that you can share with us, if you have advice to give us on how to improve the energy statistics that we have for Nigeria, again, we are really looking for partnership and cooperation on this in order to show to the world a good quality Nigeria energy balances. Thank you, everyone, and have a nice day. Bye. See you tomorrow. So tomorrow it will be me and Nicola together that will do the session. Bye.
Bye. Goodbye.
Bye. Thank you, Zakia.
Bye.
Thank you.